In this video, we will try to learn about how to draw ray diagrams. How to draw ray diagrams for concave mirrors. So for this, the material we require is a long scale, 30 centimeter scale. At times we also need a short scale, a protractor, rounder. Okay, these are the minimum things we require. We also need different colored pens. So all these are the material which we are going to use here. Now take the scale. At the middle of the paper, draw a straight line. Throughout. Now take the rounder, measure approximately 8 centimeters. By placing this on the 8 centimeter, draw a curve. Because this 8 centimeters is a radius, and this becomes the center of curvature. This point we call it as P. What is this P? This P is called as pole of the mirror. P is called as pole of mirror. This C is called as center of curvature. Exactly the midpoint between P and C is called as principal focus. This is at around 4 centimeter, denoted by capital F. Capital F is called as principal focus. PC is equal to 8 centimeter. This is also represented as radius of curvature, capital R, called as radius of curvature. Now PF is 4 centimeter. This is denoted by small letter f, called as focal length of the mirror. Compared to the focal length, that is P and F, the distance between P and F, which is of 4 centimeter, you take a far point approximately 4 times, or even more than that. 1 time, the 3rd time, the 4th time is 16, and the 5th time approximately the 20 centimeter. This point is very far away from C. This point is also called as beyond C. Now, at this point, measure vertically around 1 centimeter and draw object with an arrow mark. This is called as object, represented with O. The distance between P and O is called as PO, object distance. Approximately how much it is? Now we have taken it around 20 centimeter. Now it is 20 centimeter, which is approximately treated as infinite distance, and this is also represented with a small letter U, called as object distance. Object distance. Now the height of the object. This is 1 centimeter. 1 centimeter, which is also represented with H, O, suffix O for object. H, O. Now, we need to draw two rays. Take 1 centimeter height, approximately here at point P. Take 1 centimeter height at point P. Okay. Now connect these 2 points. This is called as incident ray. This is called as incident ray. We did not touch this point, but we have touched up to the mirror. This arrow mark indicates the ray is coming from the object, tip of the object, from here to here. Because this is treated as a mirror, concave mirror, there is opaque shade, opaque part. Now, this point is called as point of incidence. From point of incidence, we need to draw a normal. What is a normal? Normal is nothing but which is 90 degrees to the surface at that point. As we know that the normal is nothing but the line which is connecting the point of incidence and the center of curvature. This itself is the normal. Now, because the light ray is coming, incident ray is coming from infinite distance, as we have already mentioned, it is infinite distance. Therefore, this light ray is coming from infinity will always be parallel to the principal axis. This is the principal axis. Right? We will write here as principal axis. Principal axis. So, all rays which are parallel to the principal axis, after reflection, they pass through the principal focus. After reflection, they pass through the principal focus. Therefore, you need to draw a line which is passing through the principal focus. So, this ray after reflection is passing through principal focus. This is reflected ray. This one is called as incident ray. This is called as reflected ray. This is ray number 1. This is ray number 1. If you want to measure the angle of incidence, always measure from the normal. So how to measure from the normal? How to measure the incident angle or angle of incidence? Take the protractor and place the base of the protractor along the radius of curvature. The center of the protractor must be at a point of incidence and the base of the protractor must be along the radius of the curvature. Now clearly you observe that it is 5 degrees, 6 degrees, 7 degrees and it is between 7 to 8 degrees. In between 7 and 8 degrees. Right? Therefore, this angle is called as angle I. Incidence angle. Angle I. Okay. So, this angle I is approximately 7.5 degree. In the laws of reflection, the first law says that the angle of incidence is equal to angle of reflection. Let us check whether this satisfies here or not. Now again place the protractor, base of the protractor along the radius of curvature. That is, this is the radius of curvature. So along the radius of the curvature, the base of the protractor is placed. Now center of the protractor must be at the point of incidence. Now measure again how much angle it is making. So approximately 7 and 8. Therefore, the angle of reflection is also the same, which is equal to angle of reflection. Angle I is equal to 7.5 degree and angle R is also equal to 7.5 degree. This is about first ray. Now draw the second ray. So how to draw the second ray? Now from the tip of the object to the pole, from the tip of the object to the pole, connect these two. Again draw another incident ray. This is the second incident ray. So now we drew the second ray starting from the tip of the object to the pole of the mirror. This is second ray. I am putting the arrow mark in this direction. That is, the light ray is coming from the object's tip and it is falling on the pole of the mirror. This is a second incident ray. So incident ray. This is number 2. Second incident ray. Okay, this is a second incident ray. This is first incident ray. Now, from the pole, the normal to this curved surface is always the principal axis. Principal axis itself is a normal. Therefore, we need to measure the angle of incidence. Let us measure the angle of incidence. The angle of incidence, here it is approximately 1 degree, 2 degree, 3 degrees. So now this is approximately 3 degrees. This is a first angle of incidence. first angle of reflection, first angle of incidence, first angle of reflection. This is I2. I will represent this one as I2. Second angle of incidence. Therefore, angle of incidence 2 is equal to 3 degrees. Then, according to laws of reflection, the angle of reflection must be equal to angle of incidence. Therefore, again place the protractor base on the principal axis and at the pole of the mirror, center of the protractor at the pole of the mirror. Find out the 3-degree angle. 1, 2, 3. So at around 3-degree angle, place the point and now connect these two, the P and this point. This is called as reflected ray number 2. Identify the point of intersection of reflected ray 1 and reflected ray 2. That is, here is a point. Therefore, this is called as the point I. This point is called I. I is for image. Previously it was O. O is for object. I is for image. HO is for height of object, the size of object. Similarly, HI is called height of image. Height of image. So the height of the image is measured. The height of the image is approximately 1, 2, 3. 3 mm. Height of the image is 3 mm or 0.3 centimeter. Height of the object is already we have written here. That is HO. So you can also write here it as HI. Height of the image. Therefore, height of the object is 1 centimeter or 10 mm. You can write it as 10 mm or 1 centimeter. This is how we need to identify the position of the image by using a concave mirror. So the ray diagrams are very useful for us. Object is placed very far away, that is around infinity. Now the image is placed between F and C, in between F and C. In order to know this is PO is P and O is image object distance. P and I is called PI is called as image distance. Let us measure it. So from P to I, it is around 5.2 centimeter. 5.2 centimeter. This is also represented with a small letter V, called as image distance. Image distance. This is called as image distance. So now we have completed the ray diagram. So here there is a first incident ray, then it has reflected through this ray. There is a second incident ray which is passing through the pole of the mirror and it has reflected back as ray number 2. So the reflected ray 1 and reflected ray 2, where they are intersected. The point of intersection of ray number 1 and ray number 2, both reflected rays, is the point where we need to identify, and this point is called as image position or position of the image. O is called as object position. Object position. I is called as image position. Okay, so all these are the names given for different. F is called principal focus, P is called pole of the mirror, C is called as center of curvature, and PC is called as P and C is 8 centimeter, that is radius of curvature. PF is called as focal length, that is represented with small f. PI, I have written it PI, which is 5.2 centimeter. What is the nature of the image? Nature of the image. Nature of the image. First point. Compare the object. It is above the principal axis. When this is placed as above the principal axis, this is called as erect. Whereas image is below the principal axis. This is the principal axis and it is below, right? So below the principal axis, therefore this is called as inverted. Inverted image. But image is inverted. Second point. What is the height of the object? Object height is 1 centimeter. What is the height of the image? Image height. The image height is only 3 millimeter or 0.3 centimeter. Comparing these two, object height and image height, this has reduced its height. Height is reduced, right? Therefore, because this height is reduced, this is called as image is diminished. Diminished image. Diminished image. The image is diminished. Object is enlarged. This is erect. This is enlarged compared to this one, image. Image is inverted. Image is diminished when compared to the object. This is approximately very closer to principal focus, but not exactly at the principal focus. Normally, all the rays which are coming from infinity will fall at a principal focus, and we are going to expect the image at the principal focus. But this is not very far. Therefore, this is formed between F and C. F and C. This can be captured on the screen. Captured on the screen. Therefore, this is called as a real image. Then what is the position of the image? Position of the object. Okay. So, position of the object and position of the image. Fourth one. Position of object. We treat it as A and we treat it as B. Position of object and position of image. So, position of the object is beyond center of curvature. beyond C, because this is C and object is very far away from C. Therefore, this is called as beyond C. Position of the object is beyond C. O is called as object position. Therefore, position of the object is beyond C. Then what about the image? Image is between F and C. Image is between F and C. Image is between F and C. So this is about the nature of the image, the position of the object and the image. So the nature of the image is inverted image, diminished image, real image, and the position of the object is when the object is at a beyond C position, the image is formed between F and C. And when this is beyond C and very far away at infinite distance, then image will form at the principal focus. So now this is how we have to draw the ray diagrams. Thank you.